Alright guys, so just to practice using what we learned in the Real Number System podcast, on your notes page, go ahead and draw two circles like so. You can just put n on top of one for natural and maybe an x on the other side for not natural. And I'm going to scroll down here and we're going to sort these 8 numbers down here. Okay? So what I want you to do right now is pause the podcast, take a minute and write each of these numbers in the circle that you think it belongs to. If it's a natural number, write it here. If it's not natural, write it here. And then once you have that done, unpause the podcast and we will check the answers. Okay? So go ahead and pause and give it a shot. Alright, now that you have had time to try it on your own, let's go ahead and go through these numbers. Okay, so we have the number here, 3/4. This will obviously be not natural because it's not a whole number. Okay? Remember, natural numbers start at 1 and go to infinity. Okay? 0. This is also not natural. Remember, that's the first element in the whole number system. Natural starts at 1. Okay? So that one goes there. 4.9. This will be not natural. Because, once again, it's not a counting number. Before we let this go, do you have any guess what set this goes into? If you remember, 4.9 would be rational because that decimal stops or terminates. -2. Does that look natural to you? The 2 looks good, but because it's negative, it is not natural. Because it's a negative whole number, it would be an integer. Alright, let's go to 80. What do you think of that one? That will be natural. Even though it's a big number, if you were to start at 1 and count up to infinity, you would land on 80, so that's natural. 15. This will also be natural. 9/3. Looks like a fraction to me, right? And we said fractions are going to be rational, right? Let's see here. Oh, that is wrong. It's going to spit it back out here like that. Do you guys see why this will be natural? Because although it's a fraction, if you look at it, 9/3 is 9 divided by 3. When you do that, it simplifies to 3. Therefore, it is natural. Okay. And the last one, number 4. That one is going to be natural as well. Okay. Alright, let's try another one. Alright, so draw 2 more circles. Now we're going to practice with integers or not integers. So label one circle J or Z on the top because that's the abbreviation for integer. Just put an X on the other one for not integer. Alright, so I'm going to uncover here the 8 terms for you to sort. So take a second, pause the podcast, once again write them in the circle where you think they belong, and then we'll check it. Alright guys, so now that you've had time to try to sort whether it's an integer or not, let's go through these. First number is -35. Remember, the definition of an integer is a positive or negative whole number. Therefore, that is an integer. Okay. 0. That is also an integer. What about 1? Integer. Okay. And then we have here square root of 121. You might have your perfect squares memorized. If not, punch it in the computer. But if you do the square root of 121, it comes out to 11. Therefore, it's a whole number, integer. Okay. Square root of 50. What do you think about that one? Okay, once again, if you're not sure, go to your calculator, punch in the square root of 50, and just bottom line, because it's not a perfect square, and pretty much any imperfect square will be an irrational number. And just to see it, if you punch it in, you get 7.071067811865547, etc. So there's no repeating, and it's just obviously not an integer. That's irrational. 3/5. Integers are positive and negative whole numbers. 3/5 is not whole. Therefore, it is not an integer. That would be rational because it's 0.6. That decimal terminates, which looks like the same thing here. That's a terminating decimal. Not a whole number, not an integer. And lastly, we have here 0.555 ... It is repeating 5. It's not a whole number, positive or negative, so it's not an integer. It is a rational number because the decimal is repeating. Remember we said that. Okay? Alright, last set of practice. 2 more circles. This is the trickiest one. Rational versus irrational. Alright, label the top of this circle with the Q for rational, I for irrational. Alright, so once again, you're going to sort these 7 terms while you have the podcast paused. Unpause to check your answers. Alright, so now that you've tried it, let's go through this. A square root of 10. Once again, anytime it is an imperfect square, which 10 is, it will be irrational. And just to prove it, if you punch it in the calculator, you get 3.162277660168337. That is not repeating. Okay, non-repeating decimals go to irrational. Pi, irrational. It goes on forever, does not repeat. Let's look at this number, 0.138467295, and it goes on forever. I see nothing that repeats, therefore it must be irrational. Okay. Alright, next term on the bottom, 2.8. Look at this decimal. You'll notice it stops. It does not go on forever. Anytime a decimal stops, it is rational. Alright, here's another one, 0. Alright, you didn't have a chance to do that one because it was covered, but 0 would just be a rational number. Okay? And you might be wondering why, because rational numbers, remember the definition is anything that can be written as a fraction. Can we write 0 as a fraction? Yeah, we could do 0 over 1, 0 over 5, 0 over 10. 0 over anything would equal 0, so we can write that as a fraction. Even though it wasn't there, we could rewrite it. Okay? -6, rational or irrational? Well, once again, that's going to be rational. We could write that as a fraction simply by just doing -6 over 1. That's a fraction. Therefore, it's rational. 5/6. Alright, that's a fraction. Therefore, it's going to be rational, because remember, irrational numbers cannot be written as a fraction. So automatically, that will be rational. Okay. Here's another one that was covered up. 0.222 ... The 2's repeating. Once again, that's a repeating decimal. That means it has to be rational. Okay. And the last one, 40. Alright. Can we write 40 even though it doesn't look like it? Can we write it as a fraction? Yeah, we can do 40 over 1, 80 over 2, 120 over 3. Therefore, it is rational. Okay. Alright guys, so that's it for the podcast and the practice. Alright, keep practicing.